Okay, so let's go ahead and get going. One of the things is I do this every semester for each exam. You should expect that. There's a period in March where I'm going to be in LA for a research experiment. So I'll probably do this online. You'll see some of my past reviews are like that as well. Those are all I posted to a YouTube channel because I got tired of sending 4 announcements for each midterm, each time for each semester. So I just put them on YouTube for everyone to watch. It's pretty straightforward. And email me if you have questions. My email, I have my office hours tomorrow afternoon, 12:30 to 1:30. Or email me if you have any questions, post on Piazza, the whole shebang. So what questions do we have? Yeah. I can absolutely explain the span. Okay. So an overview on what this exam is, right? And I don't mean this in an offensive way, but you guys haven't learned a lot this semester yet, right? You've learned what spans are and what solution sets are, and it just about ends there, okay? So what I would expect for this exam is I would expect a true or false, a page of true or false. The second page was short answer. There's some seats up here as well in the front for not this one around, but whatever. So true or false, some sort of short answer, maybe another page of like give an example or is this possible? And then it's usually 6 or 7 questions with the following, like the last 3 or 4 being some kind of quantitative stuff. Just calculating, row reduce, show me a solution, find the span. What does this look like? What's the shape? Okay. So to talk about span, I'm actually also going to talk about solution set, just to talk about it all at the same time. Okay. And again, if I could boil down this whole first exam to 2 things, it would be span and solution set. Okay. So how do we define these 2? Let's start with span and solution set. Oh. All right. So what exactly is span? So when we talk about span, we're talking about vectors particularly, okay? You have to be given a set of vectors or you have to be talking about some sort of geometric space to talk about a span, okay? And what a span is, it is all linear combinations of some vectors, whatever they may be. And what this will usually be notated as, it'll be some kind of like span of nice curly brackets, v1, v2, v3, v whatever, okay? So this is the same thing as saying span of v1, v2, v3, okay? So you notice I've written down linear combinations. We have to talk about what a linear combination is first. So what are the things we can do in terms of linearity? Does anyone know the definition of linearity or what it's enclosed under? This is a little bit beyond the first exam, but just to talk about it, to talk about what a linear combination is. Does anybody know those things? It's okay if not. Okay, I understand. So what linear means is it means we can add and we can multiply by constants. Those are the 2 things that it means. The third condition is it has to contain 0, okay? So what a span has to do is it has to contain 0, and you can add vectors and you can multiply vectors by numbers, okay? So it's just a little aside. Linear combinations. They're combinations of vectors such that, let me just write this coherently. Linear combinations of vectors, v1, v2, v3, etc. And we write these linear combinations as some number times v1 plus some number times v2 plus some number times v3, etc. Okay? So this is what a linear combination is. It's just combining vectors in any way that we want, okay? We can't multiply vectors together. We can only multiply vectors by constants, and then we can add different vectors together within a span, okay? So what a span is it's extrapolating these and expanding them. So on a graph, what this will look like is if we have a graph, I give you vector 1 and vector 2, okay? Well, we'll start with just one vector. So the span of vector 1, okay, we can't add any other vectors because if we're only taking the span of vector 1. So it's all scalars of v1 to positive infinity and to negative infinity. Okay, so we call this a span of v1. Okay, This is kind of what a span looks like, okay? The way I like to distinguish the two between span and solution set, apart from the actual difference in shape and stuff, is span is like geometry with vectors and spaces and stuff. And solutions are how we get there, okay? It's the actual numbers and the x's, x1, x2, x3, xyz, whatever you want to call it, okay? So, going on in terms of span, one of the biggest things you need to know is what is the shape of span, okay? Okay. So how can you always determine what the shape of a span is of a matrix, okay? So how a question would be written would be, given a matrix A with column vectors V1, V2, okay? Column vectors are just the columns as vectors, you just slap parentheses around them, okay? The shape will always be R to the number of pivots in R to the number of rows, okay? And I have to put these little quotations around the first part, okay? Because what I mean is I don't mean like R2 and R3, okay? I mean a two-dimensional thing in R3. So what that equates to is a plane in R3. If we had 2 pivots and 3 rows, okay? This is something you should expect to see on your midterm, okay? This is a big one. They'll ask you shape of solution set. They'll ask you shape of span. Yeah, so, and if there are any questions at any point, please stop me, interrupt me, and I promise if you have that question, somebody else in this room has that question as well, okay? Yeah. So it's R to the number of rows because the way we write like A, right, is we have like V1, V2, V3, V4, right? And each of these vectors have 1, 2, 3, however many entries, okay? So each, in this particular case, each vector has 4 entries, so that's where it lives. It's in R4, okay? So this is when we talk about span. You can imagine when we talk about solution set, it's the exact opposite. So we'll get there when we get there. Does that answer your question? Okay. Cool. So I'm sure we're going to go through some actual like questions on how to find span and determine the shape of it and things like that. But these are the most important things to kind of look at right now, okay? Is the span is all linear combinations of some set of vectors, and the shape of it is determined by R to the number of pivots and R to the number of rows, okay? I believe you guys have talked about linear independence as well at this point, right? Another way to word this is your span is the linear combinations of your linearly independent vectors, okay? That's what the span is. Because you can have a span with multiple vectors that only creates some small, like, that creates a space that's not as big as the number of vectors. Like if I have span of 1, 0, 0, 2, 0, 0, okay? Span of this, so we're in R3 because we have 3 rows, all right? So 1, 0, 0 looks like this, and 2, 0, 0 looks like this, okay? So the span of this first vector is going to look like this, and the span of the second one is going to be exactly the same line, right? Because they lie on the same line, it can't really branch off of it like that, okay? And to show what this would look like with a different vector, so we have 0, 1, 0, okay? So how many pivots do we have in this matrix? That is 1, 0, 0, 2, 0, 0, 0, 1, 0. How many pivots do we have? So what does the span look like? It is A in, yeah, exactly. That's how that works, okay? So what this looks like in this particular case is we draw the span of those 2 lines, and then we draw the span of our other pivot column. So it looks like this, okay? That goes negative infinity and positive infinity. And since it's a span, it's the linear combinations. So for instance, we could add, we could add like a vector that goes to here, plus a vector that goes to here, or a vector that sits here, okay? And what that means is I can get anywhere on this flat plane, okay? So pretend like it's kind of easier to see in space rather than written on my iPad. So if I have like X, Y, Z, so I have a vector pointing in X, so it makes this line. I have a vector pointing in Y, so it makes this line, okay? The combinations of these, like for instance, if I wanted to get over here, I would go this far in Y and then this far in X, and add them together. Okay, it's kind of the idea of what a span is adding these different vectors together to get anywhere on their combinations of things. Yeah, and that is the entire definition of span. Do we have any questions on any of that? Yeah. For this example, this is a plane in R3 because there's 2 pivots and we have 3 rows. Okay. So now we back up a little bit. Any other questions on big picture span stuff? And one thing that I do like to say is if you have a stupid question, I promise I've heard stupider. And that's not a challenge, but it's okay if you feel some kind of way like that. Please ask those questions anyway. Yeah. I don't do y'all's homework, so I would have to look at the question. So this has 1 free variable, that's correct, yeah. But that doesn't have anything to do with span. Yeah, so this has 2 pivots, so its span is a plane. Yeah. Okay. So now we talk about solution sets. And what solution set is exactly what you'd think about, is it's a set of solutions. So we say it's all solutions to the equation AX equals B. Okay. So with this, we're going to go a little bit deeper with, yeah. Yeah, this is what the general shape is. What's going to happen is during the exam and the final and everything else, they're going to give you a matrix and they're going to say, what is the shape of the span? Or what shape does this span create? And then you write it as it creates a number of pivot dimensional space in R to the number of rows. Okay. Yeah. That's for solution set. Yeah. So solution set is all solutions to the equation. All right, and we're going to talk about this, and it's going to get a little bit complicated, but we'll get there when we get there. So all solutions. So with this, we kind of have to talk about consistency before we can even move forward, okay? Because for span, we don't need a vector B to talk about span. We only need a matrix A. But to have solutions, you have to know where you're trying to get, what your B vector is, okay? So if consistent, what does that mean for solution set? You hear a lot of mumbling. Does somebody want to confidently answer? Yeah. Yes, if it is consistent, what does that mean for AX equals B? Yeah. B is in the span of A. Yes, but let's take it in terms of solution set, and let's say it has a solution. How many solutions does it have? Well, it has 1 or infinite solutions. Okay. If it's consistent, on the opposite end of that, if it is inconsistent, how many solutions do you think it has? 0. That's pretty straightforward. A lot of the span and solution set stuff works in converses like that. Okay. So how do we find solution set? Okay. Well, there's a pretty simple process, and it basically always, yeah. We will get there. Okay, so I lost my train of thought. Solution sets. Okay, we'll talk about the 1 or infinite. So let's talk about the shape of it first. Okay. So we had shape of span. Now we have shape of solution set. Okay. You can also assume this will be on your exam to some degree, right? So since the shape of the spans are to the number of pivots and are to the number of rows, what do you think the shape of solution set is? R to the number of 3 variables in R to the number of? Thank you. Much appreciated. So yeah, these are the 2 like opposite ends of that. So that's what you were saying with 2 free variables, it creates a plane. That's what this is, okay? And these quotations go here as well, all right? So for instance, if we had 4 free variables and we had 6 columns, we would say it would create a 4-dimensional space in R6, okay? And that's kind of how you would word it for things bigger than like a line, a plane, or a point, okay? So something else to note is how many points are there on a line? It's not a trick question. There's an infinite number of points on a line, right? How many points are there on a plane? Infinite. A 3 space? Okay, how many points are there in a single point? 1. So that's what creates this 1 or infinite thing, okay? If you have any amount of free variables, you're going to have an infinite solution set, if it's consistent. If you don't have any free variables, you're only going to have one solution, okay? And if you don't have any free variables, what this is going to be, it's going to be r to the 0 in r to the number of columns, okay? What is r to the 0? It's just a point, okay? Something with 0 axes to move upon is kind of how you can think of that, all right? So something that can't move is just r to the 0, which is a point, so there's one solution, okay? So we talked about consistency for solution sets, so now let's talk about it for span, okay? If we're given a b in addition, okay? So if we have a b, for a, x equals b, to be consistent, means what for the span? If ax equals b is consistent, what does that mean in terms of span? B is in the span of A, okay? This means B in span, and I'm just going to write this like this, span of A, okay? In about a week, we're going to learn a new term for span of A that means span of A, but it's just called something different for absolutely no reason, okay? So that's what consistency means. So on the opposite end, what do you think it means? If it's inconsistent, is B in the span or out? Out, exactly, okay? So these are the overview of span and solution set, okay? Do we have any questions on what they are before I tell you on how to find them? Okay. So I like to draw this little like decision tree, if you will, of how to solve one of these problems that you're going to see on an exam, okay? So you're going to be given some A and or B, okay? I like to say it to my studio, the golden rule of linear algebra is always to put it in a matrix and row reduce. That should be your first step on any of these questions where they give you these things, okay? Step 1 is always reduce row echelon. Always. Or at least 95% of the time, but particularly for your first exam, okay? So this is how we set up for both span and solution set questions, all right? From here, we split off. We're going to talk about span. We're going to talk about solution set, okay? Zoom out just a little bit. So once we're in reduced row echelon form, for span, for this step, it's implied that you check consistency. Okay? So for span, what you're checking first is pivots, okay? Particularly the number of pivots, okay? And what these are your linearly independent vectors that form your span. What I mean by that is a linearly independent vector is a vector that has a pivot in it in the matrix A, okay? So when we row reduce, we're going to be able to tell our number of pivots, and we tell our number of pivots, we can tell the shape of the span, okay? That's as much as you'll be asked for this exam, okay? It'll be, is this in the span, which is this consistency step, or it'll be, what is the shape, which is the number of pivots, okay? So, in my opinion, the span question is a much easier question than solution sets. And if you check for like last year's exam, Professor Goldstein was actually the course coordinator, opposed to Dr. Jankowski. And there were 3 questions back to back asking solution sets, which I didn't think was very fair, but I don't write these exams. So that's kind of like the hardest kind of like quantitative computation question you should expect, is finding a solution set, okay? So for solution set, instead of finding number of pivots, what you're going to do is you're going to take the reduced row echelon form. You're going to check the number of free variables, okay? And then I'll tell you your shape. And then we can actually solve for what the solutions are by putting in parametric vector form. And this is what we call our solution. Okay? So if they ask you for, they give you a matrix A, they give you a matrix B, they say find the solutions. Step 1, put in a matrix. Step 2, reduce row echelon form. Step 3, count your number of free variables just to make sure you know the shape of it. Then you put it back out, you plug it back out into equations, and you put it in parametric vector form. And then you pick, if they ask for any one solution, you just pick your free variables to be some random number, and then you have a solution. Okay. So, any questions on this? You'll probably find this in my past reviews as well, and some variants. Again, I never bring notes here, so it's always a little different, but it's all the same thing. Yeah. Mm-hmm. Yes. What point does it span? 0, exactly. You can't go anywhere, right? Because you don't have any vectors. Like if everything's 0, that's the only case you can have all free variables, right? Okay. So as soon as you have that, as soon as you have a B that's not 0, you have a pivot in the right-hand column, and then everything else is inconsistent, so you don't have a solution. So the only time that particular case would have a solution would be if B was 0. So the span is a singular point, and that is the only case that will ever happen. Okay. A good question that you should expect, or something that is fair for the exam, would be like, give an example of 3 vectors that span a plane. Or give an example of 3 vectors that span a point. Or give an example of 4 vectors that span a plane. Or any kind of combination of things like that. Okay. And the way you do that is you just make vectors that only have that number of pivots. Okay. And if anyone wants me to do that, I can do that. Just ask. So, okay. So this is my general overview for now. Are there any particular questions from past exams, homeworks, quizzes, anything like that we want to go over? Yeah. Absolutely. So, parametric vector form. What if we have a matrix that looks like okay. So I give you an augmented matrix that has A and B, okay? This is always your part of A, and this is always your B, okay? And then your columns create x1, x2, and x3, okay? What you're going to find is when we row reduce this, we put it in reduced row echelon form, what we're going to get is we're going to get 1, 2, 4. Well, this is just row echelon form first. 1, 2, 1, 4, 0, 1, 1, 0, 0, 0, 0, 2, 0, 0, 0, 1, 0, 0. Okay, so here we have reduced row echelon form. Okay. So we're here. Is this in reduced row echelon form? Yeah. That's another thing that you will see on the exam is probably, is this in reduced row echelon form? Okay. How many pivots does it have? What is the shape of the span? It's a plane because it has 2 pivots. So it has a dimension of 2. You can call it a 2-dimensional space, or you can just call it a plane. It's the same thing. Okay. How many free variables does it have? So what does the solution set look like? A line in R3. Right. Good. So moving on from this to put it into parametric vector form and then to actually get a solution, okay? What we do is we go from reduced row echelon form back to equations. We have x1 plus 2x3 equals 1. Then we have x2 plus x3 equals 0. Okay. So what we always do is I like to say that we solve the lowest subscript. Okay. The subscript is the little number below the x. All right. So here we have 1 the lowest, and here we have 2 the lowest. Okay. So what this becomes, x1 equals -2 x3 plus 1. x2 equals negative x3. Okay, now we're here. So this is parametric form. Parametric vector form is when we put parentheses around it. Okay, so this becomes x1, x2, oh, sorry, I forgot an equation. So for free variables, you must always include an equation for themselves. And what that looks like is it's always just free variable equals free variable. Okay. You always need to make sure in this vector here that you have each of your variables. Okay. So we put parentheses around it, and now we get x1, x2, x3 equals x vector. Okay. In the equation ax equals b, this is what our x vector is. Okay. And when we find solution sets, we're finding that x vector. Okay. Equals negative 2x3, negative 1x3, negative positive x3, plus 1, 0, 0. Okay. And I'm just separating these out. Okay. So I'm separating all my x3s into one vector and all of my constants in another. Then I go from here, and I just pull out an x3 of that first vector. Negative 2, negative 1, 1, plus 1, 0, 0. And there's my solution. Okay. So this would be when they usually say find the solutions for this thing. This is usually a form that you can leave it in. The question will state explicitly you can leave it in parametric vector form, or it'll say give an example of a solution. Okay. So an example of a solution is what? How do I find a particular solution? What do I do? Okay, plug in for x3. Someone give me a number we want x3 to be. I like that answer. Okay, so this just becomes 1, 0, 0. Okay, cool, very nice. So this is the part where solution sets get a little tricky before I keep going and show how you can check this on an exam. Okay, so this part here, no, not that part. Here, okay? This part is weird because it doesn't have any variable attached to it, right? It has a name, okay? We call this the particular solution. In particular, jokes aside, it's called VP, okay? And we only happens when B is non-zero. Another little thing that I will not go through the whole proof of is each B has a unique particular solution. Okay. For any B you choose, this vector will be different. Always, always, always. Okay. So an example of if they ask like how to plot it, you're not going to be expected to plot in 3D. You will be expected to plot in 2D though. So what this would look like if I was plotting in 3D, okay, is we start with this 1, 0, 0 point, okay? This is x, y, and z. And then from here we have a vector that points out negative 2 in the x, negative 1 in the y, and 1 in the z. So it points out like this, okay? And then the span, or the solution, because that's what we're looking at, it's just a line in R3. That's how that looks. Okay. And what you'll note is it does not touch the origin. Okay. If B is not 0, your solution set will not touch the origin. Okay, that is really important, especially for the whole second exam. Okay, like going forward in this class, you need to know that a B that isn't 0 means you don't touch the origin. Okay. And we'll see this in a couple problems that I'm sure will come up. But regardless, now I'll show you a way that you don't have to know to check your answer for a solution. Okay, so we said this is a solution. And again, please ask questions at any point. I see some confused faces, and that's okay, but please let me know so I can get you past that. Yeah. There is not a trivial solution for a non-zero B. So no, it's not the same thing. A trivial solution is something that's trivial, which means we plug in all zeros to get 0 out. So that'd be if you had b equal to 0. Okay. Non-trivial solutions are when we have these things, or we have a solution that isn't just 0. Okay. Other questions? Yeah. Yes, that is exactly right. This vector is just a translation, okay, of the solutions. Yeah. So the solution is a line in R3. That is correct. What is the span? Well, we have one free variable, and we have 3 variables. So how many pivots do we have? 2. So what shape does it take? A plane, exactly. In R3, because there's 3 rows. But yeah. Okay. So to show you how to check, and in that process to also explain matrix multiplication, because that's something else you should expect. They usually like to throw like one part of something on there that's matrix multiplying. Okay. So if we have AX equals B, okay, for our A, that's 1, 1, 0, 2, 3, 0, 4. Oh no, that's not 2, 3, 0. That's 2, 3, 1. 4, 5, 1. Okay, times X equals 1, 1, 0. Okay. So if we say this is a solution, then what we should be able to do is plug this in for X, okay, and get this equation to be true. Okay. So what I mean by that is we multiply 1, 2, 4, 1, 3, 5, 0, 1, 1 times our proposed solution of 1, 0, 0. Okay. Yeah. That's exactly right. The only question they could ask you about span in terms of B would be if B is in the span. And then that's just checking consistency. So, yeah. Okay, so how to matrix multiply, right? So what I always like to teach this the way my pre-calculus teacher taught me. So we take one of these matrices, okay, and we put them corner to corner, okay? And what we do next, oh no, is we build bridges. We build it from this column to this row, this column to this row, and this column to this row, okay? So what I'm going to do is right here, this vector is going to be my solution. It's going to be my product of these two things, okay? And how we find it is we follow these bridges, okay? So I'm also, people don't usually draw these little dashed lines, but I'm just showing them to make life easy, okay? So what we do is for this first spot, okay, what we do is we follow the bridges for the row and column it's attached to. So that is this column and this row, all right? So any matrix multiplication is just a sum of products, okay? So what it is first entry is 1, nope, that's an eraser. 1 times 1, so 1 times 1, plus we go across, so that was going across this bridge here, and then we go across our second bridge, so plus 2 times 0, plus, and then we have 4 times 0, so 4 times 0, okay? So for this next set, this next row, it's going to be 1 times 1 plus 3 times 0 plus 5 times 0. Okay? And then for the next one, it's going to be 0 times 1 plus 1 times 0 plus 1 times 0. Okay? And what you'll find is this is 1, 1, 0, which is B. Which means we've successfully found a solution to this equation, okay? You don't have to do this on your exam, okay? This is just a way that if you're looking for a solution and you want to check it, you can do this. Yes? It is. -2, -1, 1. Oh, that's because for this solution, we just chose x3 to be 0. What you'll find is if we change these numbers up, okay, and say instead we said x3 to be, where is that equation? We said x3 to be, I don't know, 4, okay? Then that gets us the solution. -8, -4, 4, plus 1, 0, 0, okay? And we add those together, and we get -7, -4, 4. Okay? Yeah. Okay. Here, because this is me writing AX equals B, okay? So like we said, this is A and this is B, and this is X, which is our solution. So that's what I'm plugging in here. Huh? This is what my answer should be, okay? Our X is this vector here. That's one of our solutions that we chose, okay? So another example that I'm not gonna work out is if we picked x3 to be 2, if we matrix multiplied A times the vector -7, -4, 4, you're also going to find that this is equal to 1, 1, 0. The miraculous thing about solution sets is when you solve them correctly, they work. Yeah. Yeah, I just chose that because it was easiest to pick 0 to be my free variable. Like here, I just chose this number to be 0, and then it's 0 times this vector, which cancels out, right? And then the only thing left in my solution is this part here. Okay, so we can pick x3 to be whatever we want. It's a free variable, right? Okay, so let's pick it to be the easiest thing we can think of, which is the number 0. Okay. So when we pick it to be 0, we have 0 times the vector -2, -1, 1, plus the vector 1, 1, 0. Okay. Then we have -2 times 0 plus 1, -1 times 0 plus 0, and then 1 times 0 plus 0, and that just gets us with this vector here. Because this one is multiplied by 0. Okay. Cool. Okay. Other questions? Yeah. No, that's our solution. Okay. So I'm going to say this, and I mean this to not confuse you, but to give you an idea of the actual difference between the two. Okay. Solution sets, we solve everything down, and then our solution set is still considered a span. Okay. Because it still creates some kind of line or anything like that. Okay. But it's different from the span of A. All right. That's why we call it something different. Okay. When we get to the end, it's still x3, which is any number we can pick, plus some other vector times any number we can pick, plus in general, not in this particular case. So then we can just pick x2, x3, x whatever, and that creates our solution set, which is the same idea of a span. If that doesn't make sense, don't get hung up on it and just move on. Okay. Okay, other questions? Yeah. That's a really good question. I'm gonna get some water real quick, and then I'll answer. Okay, so the relationship between span and solution set is a span is where you can go, and a solution set is the directions you can take to get there. Okay? So for example, if I'm on this table again, okay, and I have x, y, and z, okay? If I have x and I have y, okay, and if I have two different vectors in x, right? Like say I give you 1, 0, 0 and 2, 0, 0, okay? To get to the point 2, 0, 0, I can just multiply my vector 2, 0, 0 times 1, or I can multiply my vector 1, 0, 0 times 2, or I can multiply my vector 2, 0, 0 times 2 and subtract 2 times 1, 0, 0. So we can get there is in the span. The number of ways, the number of steps we can take to get there itself is the solution set, okay? That's kind of the difference. I know that it's really hard to kind of wrap around or understand conceptually. But the big thing to understand, span is where you can go, and your solutions are how you get there. Okay? That's kind of what it boils down to. All right? In a really easy example, okay, if I'm just on this table here and I have x and y, and I only give you a vector and y, okay, there's only one way to get everywhere. Okay? Does that make sense? All right? There's one way to get there. That means we have no free variables because there's only one way to get there, not an infinite number. Okay. So that's it. It's hard to articulate exactly because there's like a million ways to interpret all of these different terms. Okay. But to get there with like one step is if you have one free variable, but you can get to the whole line. If you have, so that's one way to get there. If you have two things on this line that you can vary to get there, like you way overshoot it and then you come back, or you way overshoot it and then come back even more. That's different ways to get to the same place. And that's your solution set versus your span. Okay, does that kind of make sense? I hope. Okay. No. No. Okay. There are very, very weird cases where they will look the same, but they don't mean the same thing. Okay. You will not see any of those. Cool. Okay, yeah. Yeah. What was that? Span is basically like a map. Yeah, exactly. That's right. Yeah. So another way to think about it is just if I'm walking around this room, right? I can walk around on the floor all I want, but I can't fly, right? So I can span this entire floor, and I can get there an infinite number of ways, but I can only, like, I can't go past it. There aren't more solutions beyond that, okay? Does that make sense? Okay, good enough. Yeah. Yep. That's correct. The shape of both can be the same, okay? But they are different things, okay? So you can have one pivot and one free variable. You can have a line that is your span and a line that is your solution set. They're not the same line, okay? Yeah. Other questions? Yes. Yeah. Like, do you want me to, or is that an asking can you? Okay, yeah. So again, you don't have to graph in 3D for the exam. So I'm just going to graph in 2D if that's okay. Okay. So an example would be is if my solution set is x2, 1, 1. Okay. So that means I have a vector x1, x2 that looks like this. And what my solution set looks like is it is the infinite combinations of these, where I can pick any x2. Okay. And there's my solution set. That's what it looks like plotted. Okay. If I had this plus 3, 0, okay, then it would look like this instead. Okay. What was that? Does that answer your question? Okay, cool. Yeah. Can you find me an example somewhere? Okay, cool. All right, if we have questions from exams and stuff, just we can start working through those because we've spent a lot of time on the conceptual stuff. Okay, so like true or false questions and everything like that is still totally on the table, and you can ask about this too. So yeah. So if they give you a set of vectors and ask if it spans R2 or R3, you would count your pivots, and that tells you your shape. Okay. So if the question was given these 4 vectors, do they span R3? You would need 3 pivots for that. Cool. Exactly. That's right. Yeah. Which last problem? My iPad has not been very happy lately. So this problem here. Okay. So if we have this matrix here, all right, and we're solving for the span, okay, or if it says to like plot the span. One, 1, 0, 2, 3, 1, 4, 5, 1. Okay. So when we row reduced, we found there to be 2 pivots, and the pivots were here and here. Okay. So that means these are the vectors that we care about for our span. All right. So when we plot these in 3D, x, y, z. Okay. So we have 1, 1, 0. So this first vector looks like this. That's not on the z, that's exactly on the xy plane. And then if we have this vector, and it is 2, 3, 1, it looks something like this. Okay. So the span of each of these individually looks like 2 lines, okay? And their span creates a plane between those lines, which is incredibly hard to draw in 3D. I'm just going to draw something that looks like this. Okay, cool. Cool. Yeah. Sure. I am hesitant to do that because it tends to confuse people, but I'm going to do it. And if you think it's going to confuse you, just close your eyes. Okay, solution set is equal to the span. Well, in this case, do you want me to write the span as the span, or do you want me to write the solution set as the span? Oh, okay, never mind then. Okay, so the span of A is just equal to the span of 1, 1, 0, comma, 2, 3, 1. And there's your span. Yep, yes. I can write the solution set as a span, okay? So I go back to my point of saying, close your ears if this, okay. So we're gonna write it over here, all right? So solution set, okay? This is equal to the span of, oh God, what was it? -2, -1, 1, yep. -2, -1, 1, okay? Close parentheses, plus 1, 0, 0. This is how you would write the solution set as a span. Yes, so these are the things you can change. This is your constant that is outside. Okay, yes. Yeah, perfect. From when? Anyone in particular? 2.1 and 2.3. Give me 1 second to pull that up. Is it 2.1, 2.2? Okay, no, you're good. Which question was it? Number 6? Fantastic. I'm only seeing 4 on mine. Oh, no, there it is. 6. Word. Oh my goodness. Is this that problem? Yes, all right. So here we have a problem from your 2.1 and 2.6 supplement, all right? It says given V1 equals this, V2 equals this, and B equals this, okay? It says find all values of H and K such that this equation, oh, that is really large. Such that this equation has infinitely many solutions, okay? I like to break these up into pieces, okay? So infinitely many solutions means what? Means a free variable, exactly, okay? What else does it mean? In terms of consistency, what does it mean? It's consistent because there is a solution, okay? So looking at this, okay. So the way I like to do these is you can change the order of your vectors before you put them in a matrix. If that confuses you, just don't do it, okay? So I'm going to write this as the matrix of -1, 4, 1, K, 1, H, okay? Step 1, put it in a matrix, always. Step 2 is reduce to echelon form or some variation of that to get your answer, okay? So we're going to try to put this in reduced to echelon form. We're going to get 1, -1, -1. Those numbers aren't really important, but 0, K plus 4, H plus 4, okay? And if I make an arithmetic mistake, please let me know. It happens. So we're here. So we're looking for something that has a free variable and is consistent, okay? So what can we do from here? What does this need to be and what does this need to be? Yeah. Okay. K plus 4 needs to be equal to 0 for there to be a pivot, right? And H plus 4 must also equal 0 for both of these to go away, or to fill in as 0. And then we have a free variable, and we have it being consistent, okay? An example of how this problem could be worded differently, that you solve it slightly differently, would be find values of k or h such that the system is inconsistent, okay? The system is inconsistent, what would k plus 4 have to be? K plus 4 would have to be 0. What would h plus 4 have to be? Not 0, okay? Because then we have like some 0 and some number, and then it's inconsistent, so it doesn't have a solution anymore, okay? Again, that's a different kind of problem, but that's something that you should be expected to see and know how to solve, okay? So obviously here we have k equals -4, h, nope, that's not a k. H equals -4, okay? And there's your answer to part A. Find all values of h and k such that this is infinitely many solutions, okay? Yeah, any questions on this? Yes. Yeah, that would be consistent, but how many solutions would it have? Would it? How many free variables would it have then? Well, you would have 0 free variables, which means you no longer have infinitely many solutions. Ah. That's why whenever I get these sort of problems, I like to underline and say what is equivalent to what and kind of what we can do from there. Okay. Was it just part A or was it all of it? Or it's okay if it's all of it. I'll do all of it. That's totally fine. Find all values of h and k such that b is not in the span of this. Okay. Let's reword this because ew. So find all values of h and k such that b is not in the span. For something not to be in the span, what does that mean? There's like 15 different definitions, but inconsistent is a really, really good one we like. So for this instead to be inconsistent, h plus k has to be, oh, sorry, k plus 4 has to be 0, and h plus 4 has to be not 0. Exactly. Because then we would have a 0 and we would have a not 0. Okay. And then we would have a pivot in the rightmost column. This is inconsistent. B is not in the span. Okay. Make sense? Cool. So the answer to that one is just rewriting h not equal. Okay. And then for part C, yeah, that is correct. Yeah, for it to have a solution, you have to be in the span. That's also why I write my name here. I also do that because in my undergrad years, I didn't know any of my TA's names. So it's okay if you forget, it's just there. I also went to the wrong studio for like 5 weeks, but it happens. Okay, so part C, find all values of h and k so that there is exactly one way to express B as a linear combination. If there is exactly one way, what does that mean for your free variables? There are none, okay? So what does that mean for this? It has to be equal to what? It has to be equal to a number, it has to be not 0, okay? What does that mean for this? What does it have to be equal to? It can be anything, right? Yeah, so if this is 0, right, then we just have some number, let's call it like 6x2 equals 0. x2 is still defined, right? It's just defined as 0, okay? So that's why for part C, the only part that matters is h can't be, was that -4? Or k, sorry, can't be -4. All right, any questions on any of these? Yes. Yes. Yeah. Only k can't be, yeah. So here, right, what we're looking for is we're looking for a situation where we have no free variables, okay? And a situation where we have no free variables means we have 2 pivots. So we already have 1, and we're looking for a second one here, and that has to come from this value, okay? So this value can't be 0 for it to be a pivot, right? So we just have to solve k plus 4 not equal to 0. And that's how we do that. Cool. Any other questions on this one? Yes. No free variable because it says exactly one way, and that means no free variables. Okay, exactly one way means your solution set's a point. All right, other questions? Yes. Spring 22? Yeah, give me 1 second to pull it up. Spring 22, calendar. Sample midterm or midterm 1? Sample midterm 1, which question? Number 1D. Okay. I'm actually going to do, boom. Okay. File. All right. So to start with D, okay? The way I always do true or false questions given a shape, okay? I always start out by drawing it, okay? It's a 4 by 3, it's a 4 by 3. I like to see it. It helps me do this, okay? Whose first column is the sum of its second and third, then this has infinitely many, okay? If its first column is the sum of second and third, yes. Yeah. I can never remember which one is M and N, so I always just write rows by columns, to be honest. And they can't just ask you, they can't give you a question and say, hey, when M is 4 and N is 3, they can't do that. They have to specify that. Okay. And the first column is the combination of the other two. The equation AX equals 0 has infinitely many solutions. There are 2 ways to tell that this is true. Okay. Number 1 is we have 3 columns, so how many pivots can we have at most? 3. Okay. So we can only have 3 pivots. Oh shit, wait. Never mind, I got that wrong. That's tall, not wide. Okay. So what we have is the first column is the sum of the other 2. Okay, so let's write the other 2 first. All right. And if the first one's the sum, what you're going to find is it's not a pivot. Okay, it's dependent upon the others, or it's a combination of the others, which means it is not a pivot. Okay. So you can row reduce this, and what you'll find is you'll have 1 less pivot because you have only 2 things that are linearly independent. Okay. So this will have 1 free variable. If it has 1 free variable, how many solutions does it have? Okay. Can the equation AX equals 0 ever be inconsistent? No. There's no way to get a pivot over there if all the numbers are 0. Okay. Yeah. Which first midterm? Like the one you're taking on Wednesday? This one? The actual midterm, not the sample. Oh, from this year. Damn. Okay. Yeah. All right. Under 1A or 1B? Okay. 1A. Okay. All right. All right. So here we have A is a 5. Oh, that's a really ugly 5. 5 by 4. Okay, with a pivot in every column. Then every vector in R5 must be in the span, okay? For every vector in R5 to be in the span, how many pivots do we have to have? 5, okay? The span has to be the entire space. Can we have 5 pivots here? Why? We only have 4 columns, exactly. So this one is, oh, come on, stupid eraser, false. Cool. Other questions? Yes. Okay. 1B, E. This one? Okay. A is M by N by N, and M is greater than N. So I'm going to rewrite this. M by N, so it's tall. Then there's at least 1 vector B in Rm, which is not in the span. True or false? So it's a tall matrix. Okay. So can I have a pivot in every row? No. The way I like to think about these, n by n, okay, just make it like a 100 by 1, okay? Because why not? It's tall, okay? How many pivots can we have here at most? Okay, so what does the span look like? It looks like a in R 100, right? So you have a lot of places you can't go. So since we have a lot of places we can't go, there is at least one B which is not in the span is true, okay? Okay, so since a tall matrix can never span the whole space, it can't be consistent for all B, or there is some B which we can't reach. There is some B which this is inconsistent for. There is some B which doesn't have a solution. All of these things are the exact same statement. Okay, other questions? Yeah. Jesus Christ. Problem 3, part C. Okay. This is a really good one. So this is actually talking about yes. I believe this is the question. This one? Cool. This one sucks. But you should be able to do this, okay? So what this is this is testing your knowledge on the particular solution of a solution set, okay? So they give us, this is the plane, such as the set of solutions, blah, blah, blah. And suppose that if B is not 0, this is a solution, okay? So what we find first, we have a thing. What's probably our first step is to do what? Put it in a matrix and? Yes, thank you. Okay, so we're here. If we go down that little decision tree we had, we're doing a solution set. So we put this in parametric vector form. We have x1 equals 4x2 minus x3. x2 is free, so x2 is x2. x3 is x3. Slap some parentheses around there. And you get x vector is equal to 4, 1, 0, x2 plus negative 1, 0, 1, x3. Okay? You should be able to read this as well as you can read this. Okay, it's just left to right. It's just kind of grouped with different parentheses. Okay. So what this question asks is for part I. Is it true that this gives us this? Okay, what this is asking is this part here a solution to this? True or false? True. Something to note is we're here. So we always have this plus particular solution, but B is 0. So what does that mean our particular solution is? 0. It's not here. It's gone. Okay. So this is what our solutions are going to look like. Okay. So can we get 4, 1, 0 from these two vectors? How? x3 is 0, x2 is 1. Okay. This can be worded in a more complicated state. Okay. What it can look like is it can say is A times 3, 1, 1 equal to the 0 vector. True or false? True. So this is just a combination where we pick these two to be 1 and 1. Okay. The way that you can tell if that is true is you can put 4, 1, 0, negative 1, 0, 1 in a matrix augmented with the thing. Okay. Because what this means is if it is consistent, it is a linear combination. Okay. It's kind of how we can use these terms to our advantage. Okay. If consistent, then linear combination. Okay. So different kind of question there. We're kind of building off that one. But so the answer to this one is true. Okay. Part 2, yes. The part I? Cool. Okay. Yes, so we're about to do that in the second part as well. But so to explain this again, what this can ask is we have two different variables here that are free, right? So what does our solution set look like? It's a what? Plane. We have two free variables, right? So just because the solution we're given isn't one of these two vectors, doesn't mean it's not in that plane, right? So we can see if this 3, 1, 1 is on that plane, means it is a solution, okay? And we do that by checking consistency, okay? So if you want to skip past the conceptual bullshit, you can just say, slap it in a matrix and see if it's consistent, okay? And if it is, then it's a combination. If it's not, it's not, okay? Yeah. I don't know, can you? Can you? So you should simplify it just to do it. But what you can also see is this 3, 1, 1 is just 4, 1, 0 plus negative 1, 0, 1. Okay, so it's obviously a linear combination. It's just picking x2 to be 1 and x3 to be 1. Okay, that's a bit harder of an example than the one is given, but regardless, yes. What? I put it here because it's technically always there, but since we're solving for 0, it's gone. Okay, and that's important for part 2 of this question, actually. Okay, so any other questions on part I? All right, so moving on to part 2, what this says is it true that this is a solution to this? That is a much harder question. This takes a lot of understanding of the material to get there, okay? So we're given that this is a solution to this, okay? What that means is this is our particular solution, okay? A particular solution is any solution to that particular b, okay? There are an infinite number of them, but they're always different for all b's, okay? So what we can say is the solution set instead is 410 times x2 plus x3 times negative 101 plus negative 3, 1, 2. Okay. So this is the solution set to ax equals 2, 1, 0. Okay. From here, what we're doing is we're trying to see if this is a solution. Okay. And if it is, what we can do is we set this equal to 1, 2, 2. And we try to check to see if it is a solution. Okay. And how we do that is we subtract this over. So we get x2, 410 plus x3, negative 101 equals 122 minus negative 3, 1, 2, which is equal to 410. Hey, would you look at that? Is 410 a combination of these two vectors? Yes, therefore it is a solution. Okay, very roundabout way to get there, but that is the way we understand that. Yes. Where did the 3, 1, 2 come from? It came from this part of the question. It says that this is a solution to this, okay? So it is our particular solution. So it gets slapped on right here to our solution set. Cool. Other questions? Yeah. Okay, any questions on this before we move on? Probably take 2 more and then we'll call it a night. I still have homework I have to do. Yeah. It is. Yes. You don't care what the linear combination is. You just care that it exists, that it is consistent. Okay. So under the same reason, we can go back to the last question as well. Okay. And we can write this part as we're solving this equal to 410. Okay. And then we solve for x1 and x2 to do that as well. All right, next question. What else? Yeah. Oh, did it? Part 2C? Oh, I did. That was true. Yeah, because we get to this point here, and we have this is equal to this, and then you can obviously pick x2 to be 1 and x3 to be 0 to get you there, right? Make sense? Other questions? Yeah. Sample midterm 1 this year? 1A, got it. Number 7? Okay. This is another good one that you should expect to see something like this, okay? This is a long one. I think we'll just do this one and call it a night then. Okay, if you have other questions, send me an email, come to my office hours, whatever. I'll be around. But insert file. All right, question 7. Another rule of thumb for these sort of things, and basically any college exam, is problem 7 will probably be some kind of tricky something rather, right? So what this gives us is it gives us let A be this. And it says write the solution set to AX equals 0 in parametric vector form and draw the solution to the graph below. This question came on last year's midterm, I believe, to some extent. And they did better because I went over it in the review session. But the year before, when they had this, I think the average score for this question was like a 7 out of 10. No, 3 out of 10, a minus 7 out of 10. Sorry, the other way around. We grade by subtracting, not by adding. So, okay. So this question says, write the solution set. How do we get to a solution set? Well, we have a matrix, we row reduce it, and then we put it in parametric vector form, right? So I'm going to skip a couple steps because I've done this for long enough to know this, that it's 2, 1, 0, 0, 0, 0, right? This is A. Not reduced row echelon form, of course. Then we just make this 1, 1/2. Okay. So when they say AX equals 0, it's just about as easy as you can get because you augment it with all zeros, and whatever you row reduce, you don't have to pay attention to the right column at all because they're all zeros. Okay. So this then gives me the line x1 equals negative 1/2, x2 equals x2. Okay, slap some parentheses on there. We get the x vector equals negative 1/2, 1. Okay, something that was so very sad when I was grading this was this is x1, this is x2. Okay, so we go negative 1/2, 1. Okay, that's our vector. And it keeps expanding on in both directions. Okay, they would switch the x1 and x2, and then they couldn't get any credit, which sucks. Just on the graph, but yeah. Oh yeah, I'm not there yet. So many questions on how to find a solution set of a given matrix. Okay, this first part is pretty easy, right? Pretty straightforward, find a solution set. Okay. All right. Part B says for some vector B, the vector is a solution to AX equals B. Okay, well that changes our solution set. How does it change it? Well, it changes us from x2 here. Also, don't get tripped up on this x2 being right here, okay? Just draw the vector as you have like an x and a y, okay? Don't think about it too hard. Okay, so here we have, this is a solution for some b, okay? Do we have enough information to draw the solution set for b? Yes or no? Why? Huh? We have a slope. Do we know where it starts? Where does it start? Yeah. So the way that this whole question is asking is, do we have enough information to draw the solution set? Okay. So the reason we do is because we have a solution. Okay. So what we do is we take the solution set to AX equals 0, and we add V particular. Okay. That's boiling down everything I've said about V particular so far. Okay. What it boils down to is you just have AX equals 0 and you add some solution for your particular B. Okay. So it becomes x2, negative 1/2, 1, plus 1, negative 1. Okay. So now instead, we start at 1, negative 1. Okay. And we go negative 1/2, 1, all the way up, and negative 1/2, 1 the other way. And there we have it. That's how we draw it. If your answer is yes, draw. We drew it. Okay. All this is giving you some information, and what you need to understand is we have a solution. So that's just where our shifted start, if you will. Okay. Questions on this? So very few got this right in the last couple exams. So yes. Yep. So since we have this plus right here, it's not really like it's changing the span. It's just changing where we start. Okay. So instead of starting here and counting negative 1/2, 1, instead, or negative 1/2, 1. Okay. Now I'm starting here and counting negative 1/2, 1, positive 1/2, negative 1. Okay. So it's just changing where my origin is how you can think about it. Okay. that make sense? Cool. Other questions? Okay, I'm getting it. Yeah. So we know it's a particular solution because we know it is a solution to this B. And that's the definition of a particular solution. Okay. Whenever you see something that says this is a solution to this, you can add it to the n. Okay. And something that may be confusing is if they say they give you a equals 0 and they say 4, 1 is a solution. It's a particular solution, but it's encompassed in your actual vectors. Okay. If B is non-zero, this will just hang out on the end always. Basically, if they gave you solution plus and slap it on there. Okay. Make sense? Okay. So for the last part, answer following the span of the columns of A. So how many free variables do we have? We decided that we had 1 because our solution set was a line. So we have 1 pivot. Okay. So that means our span is A in, boom, this last part. Any other questions on this? Any other quick parting questions as well? Did you have a question? Oh, no, okay. All right, I'll be hanging around for a little bit longer if you guys have any additional questions, but have a good night and good luck. I'll be in there with section A, so I'll see y'all then. Absolutely. Good luck. Yeah. Let me turn this shit off. Ooh.